We're going to have a great talk today. We got a lot of stuff to go through, so let's get rolling. So we'll do is we're going to go through this agenda, and what I'm going to do is invite folks, if they have questions afterwards, to come up to stage, and both myself and Antra, who's going to join us from the Fulfillment by Amazon team to talk about their use case, will both be available up here afterwards. So we're going to talk about a little bit today is motivate the purpose of what is a document database, why are we talking about this. We're going to talk about some specific use cases for DocumentDB, what we see customers doing, pain points that we see. We're going to have Antra come up on stage and share their journey. And then we're going to talk about, hey, what did we do this year? Where are we going? And we're going to sprinkle in a few demos in there for good measure to keep things interesting. All right, so document databases. As you folks well know, we have many databases at AWS. And the reason for this is we really don't believe that there's really one-size-fits-all database, right? Like, you look at the variety and the scale and the difference of all the different customers on AWS. There simply cannot be a single data model and a single database that is going to encompass all the use cases for those customers. It just doesn't happen. And this is why we have multiple purpose-built databases, because we never want developers like yourself to ever have to compromise on the functionality, performance, or scale when choosing a particular database, right? Those are things that are not super fun to have to do when developing. So we're going to talk about databases. Why document databases? Well, if you think about the document model, this is how humans intuitively think about modeling data, right? We think about hierarchical lists. For folks taking notes, or if, back in university when you took notes, you write things in hierarchical lists, and you tab, and you indent, and you have lists. That's how we conceptually think about modeling data, and JSON lends itself really nice to that data model. We don't typically think in normalized tables and rows. That's not a data model that we have ingrained in our head. It's very flexible from that perspective. JSON's really kind of the de facto output for a lot of the different APIs that we use, whether it's Yelp.com or Strava or Transcribe or a lot of the ML services on AWS. The output we get back is JSON. Even the price list API to figure out what instance prices are is in JSON, right? It's really that de facto exchange for moving data around. And then it's a really easy, natural way for us to model data in our application, right? We just throw this thing into an object or a dictionary, and that's how we use it in our app. So what do document databases do? Well, they really allow you to be able to store, index, and query data that you're already using in your application and from APIs naturally in the database. So you don't have to do this translation, which always complicates things. You just get to use it native. Right? So, whether it be from, the API, your application, down into your database, it just allows you to use JSON throughout that entire development practice, which makes folks really efficient. That's really what it's about. Okay, so when should you use a document database? Well, the two things on the left, right? We kind of talked about the data model of JSON. It's just being kind of something we naturally use. A little bit more on that is, it has flexibility, right? There's really no such thing as a schema-less database. Everything has schema, right? Like indexes and even the stuff you choose for field names and stuff, that's all schema. But it allows you to be able to evolve your data model or your basically your application without having to know what the database schema is going to be a priori, right? That's a tough thing to know how to do. If you have a very mature application that doesn't change a lot, then maybe you'd be able to lock into something. But for net new apps or for things that are iterating or continue adding features, having the flexibility in your data model to be able to do that efficiently is great, right? So that's kind of the left two bullets are more about the data model. The right three are really about the access pattern. Okay, so there's the data model, but then there's how you actually access the data within the database, right? To be able to do ad hoc queries, which really means like, hey, I want to be able to answer basically an unbounded amount of questions across my documents. I don't want my data model to prevent the types of questions that I'm going to ask of this data, right? And that allows us to be able to do very specific queries, aggregated queries, and use the full weight of the API to query the data however which way we want it. We're not bounded by that. When we want to do that, then we want to be able to have flexible indexing, right? We want to be able to create new indexes, delete indexes, and we also want our query processor to be able to use multiple index, right? Index intersection, right? We don't want to just be beholden to a single index in our application. If the query processor can pick up 3 indexes and use them more efficiently, well, we should do that. That's good. That makes our queries faster. And of course, then we can also be able, with those capabilities, we can also be able to do operational workloads, and then you can mix in some analytics on those workloads as well, with being able to do aggregations and group bys and sorts and counts and sums and averages. So, friends, I might be the only product manager at reInvent that will stand up on stage and tell you when not to use this product. Why do I do that? Believe that you guys should choose the right tool for the right job, whether that's the service I work on or not. When shouldn't you use a document database? Customers come to me and they say, hey, we really want the database to preserve the integrity of the data model, right? So this is a case where you have, like, say, a doctor's table and a patient's table, and you want to delete a doctor, but that doctor is attributed to that patient, so if you delete that doctor, you're going to orphan a patient. If you want the database to enforce the integrity of the data using something like primary foreign key relationships, that lends itself really well to the relational model, right? Similarly, if you have a really good known access pattern that just does primary key lookups and you need infinite scale, that's a really great use case for a key value store, right? That's what key value stores were made for. It was very structured access patterns to primary keys. We have a lot of customers that come to me and say, hey, Joe, I want to store all this binary data in DocumentDB. And I go, that's really great, but have you considered just storing that data in S3? It's going to be a heck of a lot cheaper for you. And then just using a document to describe what that S3 bucket is, and then reference the S3 bucket URL within a document. That might be a better solution. There's been a lot of blogs written about how like relational or document databases aren't really great at storing highly connected and social graph type data. I agree with those, right? That's why we have graph databases. If you're like Nike and you're building a social app for millions of your customers so that they can understand who's following LeBron James or Cristiano Ronaldo, we're probably going to want to use a graph database for those types of workloads. So what we see, we see a broad set of customers using DocumentDB across virtually every segment that we come across. A lot of the use cases, right, we see in product catalogs. And you think about Woot.com. How many people have ever bought something from Woot before? Right? Online shopping. Their product catalog runs on DocumentDB. And why that makes sense is you think about the variety of products that they actually have to sell. And from all kinds of different vendors, and a toothbrush is going to have a different description than a bar of soap, than an orange or a t-shirt, right? They don't have a schema they can just say, hey, this is just how we're going to describe all the products on our site ever. And they need to be able to ask a lot of different questions of that data. How many of this particular product sold in this geographical region over these dates, or what is the cost of this thing? How much inventory do we have left? Right? They need to be able to have an access pattern where they can really ask an unbounded amount of questions of their product catalog. FreshHop is another really good example. They provide a back-end service to enable grocery stores to get online, right? As we kind of seen, this is a pretty popular thing now where a lot of people want to be able to shop online for groceries as well. And this is a very competitive space where there's lots of people trying to do stuff. You need a data model that's going to allow you to iterate fast. You don't want your developers to be able to be locked in a particular schema or have to be able to spend time doing that. You want to be able to move fast. All right, so why DocumentDB? Why did you guys build this thing? What are the challenges you're seeing? So conversations when I talk to customers usually go in 2 ways. One, self-managing is hard, right? Self-managing databases is hard. The story typically goes like this. I work on a team. I'm the manager, software development manager for a team. Somebody built an application 3 years ago. They chose this particular database. None of those people are on the team anymore. I now own this thing. I don't know, nobody on my team has expertise in it. We don't know how to do high availability. We're struggling to do patching. We don't even know if it's backed up or not. can you please help me get to something that's fully managed so I can take those valuable developer resources and not use it on the undifferentiated heavy lifting, but use it on evolving my product and adding value for my customers, right? That's the first set of conversations we have. The second one is, scaling my database is hard, right? It is hard, right? I have to, whether it's scaling for reads or writes or storage, or I've kind of got to this inflection point where I think I want to shard now, but I really don't want to do that because the operational complexity increases significantly, and so does the cost. Now it kind of changes the way I use my database because those two things aren't the same. And folks just say, hey, can you help us scale easier on this thing? So when we built DocumentDB, we worked backwards from these customer scenarios, and we really thought about how we were going to do this thing, or how we were going to build this. What would it look like? Well, first it'd be fully managed, right? People don't want to be in the business of doing this anymore. And that's perfectly understandable. Scalable, and then of course MongoDB compatible, right? The MongoDB API is by far the best way to work with documents. When we thought about building this though, we really broke down the assumption of saying, well, let's not be beholden to architectures that exist today. Let's think about knowing all the things we built about building distributed systems and things in the cloud, let's build it with a cloud-native database architecture. So first, fully managed. What does that mean? Well, first and foremost, we handle high availability in the configuration and replication and storage detection failures and recovery and that whole lot. All the provisioning, that stuff you don't have to worry about. Patching, right? OS level patching, database level patching, we do all that for you. It happens on a regular basis, not something you often have to think about. And then integration with other AWS services, right? Monitoring goes to CloudWatch, auditing goes to CloudTrail, integration with CLI, CDK, CloudFormation, Secrets Manager, and more. And the one that I love the most is backup, is a fully managed service. Backup on DocumentDB is enabled by default for a day, and we don't even let you turn it off. And why is that? Well, I believe very fundamentally that databases should be backed up and backed up regularly, so we offset that cost for you so that you don't have to think about it. We care a lot about safe defaults. If you provision a cluster in the console, we will default you to TLS enabled by default and also encryption at rest by default. You can turn those off, friends, but you have to turn it off, right? You have to make an explicit decision to go do that. I will put you in a safe position. You have to opt out of that. Similarly, DocumentDB is VPC only. You get that strong network boundary so you're not exposed to the internet. Highly available by default, durable by default. We even added a feature this year called deletion protection, which actually makes it even harder for you to delete your clusters. And I've had some of you reach out to me and say, it's too hard to delete my cluster. It's kind of the point. People accidentally delete their clusters, and then it becomes very painful then, because recovering things that are deleted is not fun. All right, so that's the fully managed bit, right? It's now scale. When I talk to customers, a lot of the times the conversation starts here, right? We are here, we are gonna go up and to the right, we're gonna grow at N% year over year. It's super easy to scale the application tier, right? That thing's stateless, you just scale horizontally, no problem. It's pretty hard to scale the database tier. How can you help us so that our database tier can scale with our application? And this is where we spend a lot of time in DocumentDB on this architecture of being able to scale in and out in minutes, having storage auto scale, and then being able to load balance across your replicas and be able to use those as read targets. So they're not just high availability targets, but there's something that you can use within your application to actually scale reads and get a lot more bang for your buck for the hardware that you're paying for. All right, so how did we do that? Well, cloud native architecture. So let's start with what are the challenges with existing architectures. Well, existing architectures, this is document databases, relational databases, just as kind of a period of the time. We're meant to run on laptops, on servers underneath this thing. They were really built in an era in which you had the assumption that you had some type of attached storage, right? And these things are monolithic in nature and such that the unit of replication is the whole stack, right? And that makes it really hard to scale these things, right? Because they scale as a monolithic unit, and then failure recovery is also, you have to recover that whole monolithic unit, right? And so every time you need to do one of these activities, you have to stamp out an entire one of these stacks, and that takes a lot of time depending on how much data you have. I have some customers that come to me and tell me that, we have a lot of data, we have terabytes of data, and sometimes we measure the time it takes to add a replica in the course of days, sometimes even calendar weeks, right, just to add a replica. And I don't even measure vacations in calendar weeks, right? We're not afforded that luxury. It certainly shouldn't take a database that long to be able to add additional read capacity. Great, so that's fine, Joe, but what did you guys do differently? Well, the first thing we did is we separated storage and compute in DocumentDB, right? You decouple these two things. You've heard Warner talk about this many times, whether in his blog or through his talks, is it's really about decoupling the monolith. We do it in the application tier, why not do it in the database tier? And what that allows us to do by separating storage and compute is that these two things can scale independently of each other. And that provides a tremendous amount of value for databases, is these things don't have to scale as monolithic units. We even went one further and said, well, let's not have this huge monolithic disk, but let's actually break up the disk into 10 gigabyte partitions and then replicate these things 6 ways across 3 AZs. And why that matters is that imagine recovering the time it would take to recover, say, a 1.5 terabyte disk, right? That's a physics problem, right? It takes whatever the network link is plus whatever compute you need to do that. How long does it take to recover a 10 gigabyte partition if one of these storage nodes goes out? Not that long, right? We got 5 other ones sitting around, so A, you're not in a bad spot even if you lose one, but if you lose one, then we just recover that in probably less than a second, right? Super fast, right? These are decoupling the monoliths. All right, so here's the architecture for DocumentDB. We have a single primary instance and multiple replicas. The replicas and the instances are consumers of the storage layer. This architecture affords a lot of flexibility for developers. One, you can start off with a single instance cluster. We have a lot of folks that, just through force of habit, believe that you need to have 3 instances to have a highly durable database cluster. With DocumentDB, this is very different. We handle this differently. Durability is handled at the storage layer. So you can have a 1 instance cluster, still highly durable, probably a dev test scenario, right, because you don't have a failover target, but it allows you to cut your cost by 66%. You don't need that third, you don't need 3 clusters. Now, as your application matures and you want to go into, say, production, you can add another instance, and your high availability goal goes up, data's still highly durable, right, not a function of how much compute you have. You can add another instance, you go up to 3 nines. Friends, if we add a 4th instance, that doesn't give us 5 nines of availability. It stops scaling linearly there. If you want 5 nines, then you gotta do the cross-region thing. But it gives a lot of flexibility. The storage is actually so decoupled from compute, we introduced a feature this year called start-stop cluster. What does that do? Spins all your compute down to nothing, so you don't have to pay for compute when you're not using it. All your storage still stays there. Come into work the next morning, start your cluster back up again, brings your compute back up. That's how decoupled they are. You don't actually need compute to keep your storage. All right, so one of the other advantages that we do is because we push the replication and durability down into the storage layer, the replica instance don't actually participate in the durability of your writes. If you think about traditional database architectures, what typically happens is you will write to the primary will send that over to the replica. Both of them kind of do this race to write down to disk on both instances, right? They both kind of come up at some time, coalesce at the primary, say, yep, we both wrote to disk, and then you return back to the client, right? That's typically how it works with traditional database architectures. In DocumentDB, the storage layer handles the durability and replication, and writes go through the primary. That means the replicas don't participate in the durability of the data, and that frees them up to do a lot more work for you because you're not concerned about writes blocking reads and reads blocking writes and this kind of confluence of traffic happening on the replicas. They basically become isolated targets for you to be able to have other read workloads work on them, and that gives you a lot more bang for the buck as you can use those with as read targets. So we actually highly encourage our customers to connect to their clusters as a replica set, right? Which means that the client is aware of the cluster topography, and then be able to choose a read preference of secondary preferred, meaning if there are secondaries, go ahead and read from them. If there's not, go ahead and read from the primary. All right, so scaling reads. How do I scale reads? Well, adding another replica in DocumentDB, takes about 8 to 10 minutes, regardless of how much data size you have, right? You could have a 10 terabyte cluster and it's gonna take 8 to 10 minutes. Why is that? The instances are not data bearing. So all that we really do here is we spin up an EC2 instance using the same APIs that you guys use to spin up EC2 instances. We lay down our bits on top of it, sync some cluster metadata, and then make it available in the cluster. Right? There's no function there that includes storage size because we're not copying that stuff around. It's just, the instance just becomes a consumer of the application. Failure recovery is the same way, right? What we usually talk about in databases is, hey, how long does it take to do a failover? DocumentDB, typically 30 seconds. What we often don't talk about, though, is how long does it take your database to be able to recover from that thing you lost? Conceivably, that thing is there because you want it or need it, right? Like those are things that you want to be there because you paid for it, and if you paid for it, then you want it there. So how long does it take to recover that? Again, it's a function of 8 to 10 minutes to spin up that EC2 instance. Some other scenarios that customers come and tell us is that, what I really like to do is come into work, scale up an instance to be able to do some analytical workloads on it, but then scale it back down when I go home at night, because I don't want to have to pay for that thing if I'm not querying it. So DocumentDB allows you to go into the console, scale up an instance in your cluster independent of the size of the other instances in your cluster, party on it all day, and then spin that thing back down at night. Scaling storage. If you've ever provisioned a DocumentDB cluster, you'll notice that when you provision the cluster, you don't specify how much storage you want or how many IBOPs you want. The reason being is that DocumentDB, I hate to say this, but is serverless in the sense for scaling storage is that you only pay for what you use, and you don't have to think about, having a capacity meeting every month to think about where you're at for storage and should we add more and doing that complicated dance. It'll scale from 10 gigs to 64 terabytes for you. All right, so a lot of the times we hear customers saying, hey, either I'm sharding or I'm up against the wall of sharding and I don't want to do that. How does DocumentDB help? First, scaling reads, right? We encourage you to scale from your read replicas. You can scale out to 15 read replicas up to R5 24x large, millions and millions of reads per second, right? Tremendous amount of scale. You can scale writes very easily, very low impact by scaling up your primary instance, and then storage will auto-scale for you up to 64 terabytes, really reducing a lot of the motivators that folks typically need to shard for. So let me show you a quick demo. We talked a lot about scale. I want to go in and actually show you a few things. So ahead of time, I created a cluster that's 1.4 terabytes. We'll round up to 1.5 because it's a nice, clean instance. And I want to do two things. I want to add an instance, so we'll call this MGM instance. We'll go ahead and create this. And at the same time, I want to take a snapshot of this thing, right? We want to take a backup of this. All right, and while those two things are working, I want to bring Antra up on stage to talk about her experience using DocumentDB with Fulfillment by Amazon.
Thank you so much, Joe, and thank you all for taking the time out to be here today. Welcome to the 8th annual reInvent. My name is Antra Grover, and I'm a software development engineer at Amazon. I'm here to share the journey of my team from why did we choose DocumentDB to power our platform, to how it helped us optimize, scale, and perform, and share some of our learnings from this experience along the way. So let's get started with a very quick quiz. Can anyone, by show of hands, find out the difference or differences between the two pictures on the screen? Yes? No? I don't know? Anything? Okay. Does anyone know what this fulfilled by Amazon on the bottom right corner of the first picture mean? Jeff Bezos' 2018 shareholder letter mentions something like this. The percentage share of sales on Amazon by independent third-party sellers compared to Amazon's own sales has increased from 3% in 1999 to 58% in 2018. May the force be with Amazon. But what force could have helped these independent sellers to expand their sales from $0.1 billion to $160 billion over the years? Let's find out. Amazon allows individuals and companies to sell their products on Amazon with their own catalogs and own prices. Fulfillment by Amazon, that is FBA, is a service purchased by these sellers to have Amazon manage their inventory for them. By manage, I mean taking care of the entire life cycle of an item, from the point the seller ships that Doodle Mom mug from his warehouses to when we receive them in our own fulfillment centers, that is FCs, and store them. Once the customer orders are placed, we pick, pack, ship, and deliver. Once delivered, we provide customer services for their products. We handle returns back from the customers. We send inventory back to the sellers as and when they need it. Now, within Fulfillment by Amazon, I work with Inventory Authority Platform, that is IAP. IAP is the single source of truth about inventory state. Tying it back to what FBA is, IAP acts as a state machine that would answer questions about the state of the inventory at any given point of time. Like, how many Doodle Mom mugs did the seller ship in the first place? How many of them have we received so far? How many customer orders have gone out? Did any returns come in? And so on. We are a real-time serverless stream processing platform. We listen to all the events across Amazon warehouse management systems, process them in real time, and send a response back to the sellers. Our end goal is to provide this reconciled view of all the inventory movements across our Amazon warehouses to our internal teams and sellers to surface via different channels. We also maintain a historic picture of all our warehouses at any given day in the past to track what happened, when, and why. Now, we've vent out this information to our clients via various mechanisms, since one size fits all simply does not work. But most of our use cases pertain to clients being able to execute online queries via our service APIs to access real-time inventory information. Some of them with very high TPS requirements, others with very low latency requirements, and some of them with computationally expensive natured queries. Now, let me ask you a question. Has it ever happened to any one of you that you launched a platform and a few years down the lane, you end up re-architecting your systems just so that you could scale and grow? Well, I feel you too. When we launched IAP 2 years back, we chose the best possible data storage solution that would work for us at the time. It was not purpose-built to cater to the exact requirements that we were looking for, but was the closest possible thing that we tried to incorporate, and we have very soon outgrown it. A couple of challenges that we have landed into are these: high TPS and large datasets. To give you an idea around what I mean by these, in the last 6 months, IAP systems have scaled to handle a couple of billions of inventory movements through hundreds of billions of Lambda invocations, storing hundreds of terabytes worth of data. Now, with this scale comes heavy resource requirements to scale both your storage and compute, which of course leads to higher costs and higher operations. So for all these reasons, we started looking out for a managed data storage solution with flexible query support that could scale per our requirements. Now, DocumentDB brings the best blend of all that we were looking for. Joe has covered why DocumentDB for the most part, but let me pick the top 3 whys that mattered the most to us. Number 1, flexible schema. New client requirements bring in new fields that are required to be surfaced via our schema, given we have visibility into almost all the inventory information that a client might be looking for. So we cannot afford to have a static schema that would have had a purpose served by relational databases. And flexible query support. We offer an open-ended model to our clients to perform free-form queries like aggregate, sort, filter on any combination of fields in our schema. So having a key value store that would provide point lookups could not suffice either. Number 2, client isolation. And this is important to us to the core. Take a scenario where you have your production storage and you're taking in production queries from over 30 different clients serving over 70 different use cases. A new interesting use case comes in with a computationally expensive natured query. Say, a range query for last 3 months worth of data meeting certain filters. So you start taking in this traffic and your CPU utilization breaches thresholds. All the use cases working in production till today without you or them making any change start getting throttled. So client isolation to us implies that one client or one single use case or that one huge shark should not be able to bring down the entire sea of production system. Now, DocumentDB does really well in segregating storage and compute, right? But it does an even better job in segregating writes, reads, and instance-specific endpoints. So in DocumentDB world, my storage is safe in a black box. My writes are being reliably and independently served on my primary, and my reads are segregated and load balanced on a replica set, and neither of them can impact one another. Now for that one new high maintenance client, all we need to do is go spin a cluster instance on the same production cluster and route all your reads to that instance-specific endpoint. Now we wait, watch, monitor, optimize, scale in, scale out, and once we have very thoroughly performance tested that new use case, merge them back to the replica set. Simple as that. Number 3, exhaustive monitoring. One of the greatest things about any AWS services, and so DocumentDB, is that it provides very detailed monitoring. For DocumentDB, these metrics are available at both cluster and per instance level. So you could add CloudWatch alarms for the thresholds that matter the most to you, like CPU utilization, read-write IOPS, free disk space, and so on. Another very interesting recent addition to DocumentDB has been its slow query profiling, where based on the sampling rate and millisecond thresholds that you configure, the entire query execution plan gets dumped into CloudWatch Insights for further analysis for any query that breaches the threshold while returning the response. So it's pretty powerful to be able to get notified for even a single occurrence of unoptimized queries before they could become a bottleneck pattern. Now, on a very, very high level, this is how our core engine looks like. IAP listens to multiple events, translates them into a consistent format, and validates them in a service. Then ingests all those transactions into our core processing engine, where these would flow through a bunch of Kinesis stream, trigger a bunch of Lambda functions. These Lambda functions would process these entities based on certain business logic, further push them into another set of Kinesis stream, which would again trigger a couple of Lambda functions, which would polish these entities, and finally publish them to DocumentDB in a client-facing format. This is where we have our client-facing APIs taking in production queries, query DocumentDB, and send the response back to the clients. Now, what did we observe post-migrating to DocumentDB? Better scaling avenues imply being able to handle high TPS, large datasets use cases with higher performance, which of course leads to better client onboarding avenues. Again, we could leverage instance-specific endpoints to segregate our performance or peak testing from our production reads. Leveraging utilities like Mongo dump and Mongo export enabled us to actually dump all the records in our cluster to an S3 bucket on a periodic cadence and set up automated validations against our upstream snapshots. All of this leading to less operations. Now, assuming all of this is a given, let's talk some interesting numbers. On the same production read-write traffic, we were able to go from 96 hosts down to 2 hosts, and our P99 latency numbers were still on the lower end than the previous offering that we had. Another very interesting point to note here is the fact that the number 96 hosts used to be subjective to the amount of data that we wanted to store in our systems. It had gone way up and down in the past based on the retention policies that we had configured. But with DocumentDB, as long as your query patterns or your read traffic is not drastically changing, it does not matter if you store 3, 6, 12, 18 months worth of data. You still use these 2 hosts. And storage in DocumentDB is very, very cheap. Now, what do you guys think happened to our performance numbers when we went down by 94 hosts? So to reiterate, on the same production read-write traffic, for these 2 hosts, our average latency numbers were 1/3 of what we used to observe before, which is a 66% performance improvement, and that is quite impressive. And on top of that, if you look at the CPU utilization of these instances, we literally consume 2 to 3% of our read CPU utilization as of today. So we could still achieve so much more scaling in onboarding new use cases without even having to worry about adding a new instance for a very long time. Decoupled storage and compute, competitive pricing, being able to configure each instance in your cluster separately has led to a 45% cost saving for us. So if I were to ask who wins here, in my honest opinion, we felt like winners looking at these results. Next, I wanted to share some learnings that we had in our journey that we wished we would have known to begin with. Some of them might come out as obvious to a few of you, so please bear with me. Split your workloads across collections. The bigger the dataset size of your collection, the bigger the index size. The longer would it take to scan the entire index, and slower would be the performance of your reads. Also, any writes, updates, TTL deletions, background processes are going to fight for resources. So we tried to split our data across collections such that our index size per collection is small enough for most of our use cases. Also, each of these collections would get their own set of resources to handle these background processes, giving more room for scaling at a better performance. The way you can think about splitting your data and thus reducing writes per collection is based on some logical separation, like having date-time-based rolling collections, or splitting by geography or by demographics. Another very interesting point, having smaller rolling collections is always better than having a very large collection with TTL enabled, because you could directly go ahead and drop the entire collection once not required, instead of TTL having to go in the background, run a lot of IO operations to delete each tail row and its respective references from each of the indexes. Now, once the inventory is received into a fulfillment center, it can happen for a very fast-moving item that we get burst of updates very quickly. And this happens all the time during Prime Day or like holiday peaks where Amazon devices would sell like hotcakes, making all these items hotkeys for us. So since all these transactions are snapshot events to us and we'll blindly go ahead and override the inventory quantities for these transactions, the way we could reduce the number of writes for these was by deduping all the incoming transactions for any given item in a single batch call. So basically, batching unnecessary writes based on certain acceptable SLAs could lead to less resource consumption. Again, updating and replacing a document are two very different things. Updating a document is something that would not happen in place. It will create a copy of your previous object, modify it, and then insert it back. Whereas replace does not really care about the previous state of your document and would just blindly go ahead and overwrite it. So when to use what? Update is when you want to partially update a document. So if you have a use case where you are trying to rewrite a document version and you want to carry over certain fields that are not in the incoming write transaction, go ahead and update. Otherwise, replace. It's a lighter operation to have. Now, DocumentDB also provides upsert functionality. That is, given a document ID, go ahead and update the document if it exists. Otherwise, just go ahead and insert it. You can tune it up one notch by performing conditional upserts that would handle scenarios like, given a document ID, go ahead and update a document if it exists and matches a certain update criteria. Insert if it does not exist at all. Ignore if it exists but did not meet the criteria to get updated. So it's pretty cool to have complex scripted upserts being taken care of in a couple of lines of code. So this was all about scaling our writes. Now let's talk about reads. This came as a very interesting learning to us. DocumentDB provides routing your reads to your primary instance, that is cluster endpoint, or to your reader endpoint, or to a replica set. Now there is a very subtle difference between using a reader endpoint or a replica set. Reader endpoint load balances TCP connections across all your replicas or your secondaries. The thing to note here is the fact that it load balances TCP connections and not the actual read requests. So if one of your TCP connections is request heavy, your actual reads might not be 100% load balanced across your replicas. Whereas in a replica set mode, the driver would make sure that your actual read requests are 100% load balanced across your replicas or secondaries by maintaining a connection pool, which worked out better for us, and it's also one of the recommended best practices by DocumentDB. Another thing, having long-running transactions, like running an EMR job to scan an entire 15 terabyte collection to take a Mongo dump. Be cognizant about the fact that it is going to consume time and resources and might impact the performance of your reads and writes. The best way to go about it is to use the beauty of point-in-time recovery. You have your production cluster. Create a shadow cluster of that production cluster by using one of the backed up snapshots. It will have the same databases, same collections, same indexes, minus any incoming production reads and writes. Run these long-running transactions on the shadow cluster and delete them once you are done. So now you know how to handle your writes, how to handle your reads. Let's talk about how to set up your cluster and your indexes. So let me ask you another question. How do you decide what instance type would work the best for you? Start from the bottom of the barrel and scale up until it magically works out? Or play safe, use the highest available compute because I got money? Or look at your TPS requirements. While all of these are very valid and fair arguments, there is one very important thing. Always choose an instance type such that your index size could fit into memory. Your queries would be exponentially more performant if you don't have to bring in a subsection of index into memory every single time there is a page miss. And on the same lines, any TTL deletions or background processes would be equally more performant. You could scale horizontally by adding more instances as your TPS size grows, or you could scale vertically by incrementing your instance type as your dataset size grows. Okay, so now you know what instance type would work the best for you. You go ahead and you set up your cluster. Everything is up and running and you're very excited. What do you do next? You go ahead and analyze your production queries and pick the top 4 most queried fields that you want to index on. What do? Create 4 single indexes or create 1 compound index with all the 4 fields listed in? It again depends. Compound indexes work very well in case of consistent query patterns because compound indexes work on prefix matches. Also, compound indexes would have faster writes because you always need to update only single index whenever you are writing into a collection. But compound indexes take up more storage space. And you need to be cognizant about the fact that you need to choose the first field to return the most restrictive result set whenever you want to have smaller query scan times. Whereas multiple single indexes would require each write to update multiple indexes, but would always lead to faster writes, irrespective of your query patterns, because your platform is optimized to always pick the index with the most restrictive result set, having smaller scan times. So in cases like ours, where we cannot predict what our client query patterns might look like, single indexes work like a charm. Now, you know what index type you want. How do you go about defining these indexes? Now, index build and creation is a computationally expensive process. So if you are starting fresh, try to define your indexes before you enable writes or inserts on your collection. Because if your collection size is pretty big, index creation might take a very long time to complete. But again, things change. New requirements come in, new client use cases come in, and you might eventually end up in a place where you would want to create a new index on your running production system. Now, there are 2 ways to create these indexes. You can either create the indexes in the foreground or in the background. Creating indexes in foreground takes a write lock on the table. So if you have any incoming real-time production writes, they are all going to get throttled until the index creation gets completed. While creating indexes in the background, they might take a little longer, but your production writes would not get impacted. So evaluate your trade-offs. Being realistic, each system will have different dataset sizes, different read-write TPS, different throughput, different nature and type of indexes required, different nature of queries, different document sizes, different patterns in peak, and each of these factors is going to determine the performance of your system. So without making any assumptions, always do performance test your system. Know what metrics to look for and alarm on, the thresholds that are most important to you. We talked about a couple of them earlier, but there were some metrics which we found very interesting and useful to look at. One of them was swap usage. This basically tells you the amount of memory that your system is requiring other than what is currently allocated to it. It should stay close to 0 because a non-zero value would imply that your system is performing an overhead job to flush old pages off of RAM into swap space to bring in the newer chunks into RAM space to serve the current queries, which means it's time to scale up. Another one was disk queue depth. This is basically the number of pending or blocked transactions on the current transactions that are being served. This queue depth should not increase consistently because if it is happening for a very long time, it's time to run current top on your cluster to find the pending long-running transactions and handle them. So these were some of the key takeaways that helped us scale and grow. And there is so much more we are still learning to get benefit from. I would like to conclude by talking about a few things that we are still exploring to capture the full potential of DocumentDB. One of them is change streams. With DocumentDB launching change streams, we are looking at avenues to short-circuit some architectural workflows where we have built in-house solutions to trigger off of any changes that happen on our cluster and process the delta whenever a transaction is applied to our inventory state, which is exactly what change streams cater to. So we are very excited about that. Also, different IAP clients require inventory quantities at different levels of aggregation. Like, what are the inventory levels in a given fulfillment center, or across all the fulfillment centers in a given marketplace, or across all the marketplaces in a given country? Right now, we are pre-computing all these quantities earlier beforehand and storing them for clients to query real time. With DocumentDB aggregation pipelines being so powerful and flexible, we're looking at avenues to collapse all these pre-compute workflows in lieu of runtime aggregations on the core inventory levels, which is going to be a big win for us as and when we get to it, because it would save us cost and maintenance of all these additional components. So with this, I would like to give the stage back to Joe. It was a pleasure talking to all you wonderful people, and I really hope you have a great time having lots of fun and making history here at Reinvent. Thank you.
All right, thank you, Antra. That was fantastic. Many of you folks may or may not know, at Amazon, our friends in Amazon.com have the same choices you folks do, right? They can choose whatever technology they want to build their applications. They are some of our most demanding, I mean, by those numbers, right? Those are some of the most demanding applications and some of the most workloads that push us the hardest. What's different about them, though, is they know where we sit because they have the phone tool icons, and they can go, or they have the phone tool, and they can find out where we sit. So they can give us feedback very directly, very quickly, which is a good thing. All right, so if you remember what we were doing before we brought Antra up on stage, we were doing a demo. So let's go back in and check where we are at. So we were doing a snapshot, right? So we started this thing, we created a manual snapshot at 2:53 on a 1.5 terabyte cluster, and that took about a minute to complete, right? That's pretty good, right? The reason why for that is we were taking a continuous stream of backups from DocumentDB. So when we take a snapshot, we're basically just putting a file marker in a continuous log stream, right? If you're gonna take a snapshot in a traditional database architecture, what happens? Basically takes a write lock on your entire database while that background is processing. You can't do that during normal working hours. Because of the separation of storage and compute, you can take a snapshot of your production database at 2 o'clock on a Tuesday afternoon, knock yourself out. Doesn't affect the database performance because your instances don't even know what's even happening. All right, we also added a new instance. We started about 2:53 for the snapshot. The instance was finally created at 2:57, so better than 8 to 10 minutes, right? We just created a new instance on a 1.5 terabyte cluster in about 4 or 5 minutes. That's pretty good. That's the power of separation in storage and compute. All right. We've been busy. You've been giving us feedback, and we've been trying to turn this around as fast as humanly possible for you folks. We've been trying to keep a very steady stream of updates to be able to unlock the capabilities that you folks have been asking us to build and in the regions that you need them. And we will continue to do this. I now have a year's worth of data from you folks to understand what is gonna matter the most for you and in the order for building those things. So we just need to get after it even harder next year and get these stuff out even faster. Some of the highlights from this year, the things that folks really wanted the most, change streams is one of them. Change streams really allows you to be able to use the data within DocumentDB in many different ways beyond the individual database, right? Change streams is basically a time-ordered sequence of events of the updates and the deletions and the insertions that happen within your database, and you can read off of those to send them to Redshift if you have a data warehousing use case, or S3 for machine learning, or Elasticsearch for indexing, or Neptune, right? It allows you to use your data in a much more flexible way across multiple services. Again, not everything we truly believe is gonna happen in the database. As Antra said, slow query logger. This is another example of decoupling the monolith. If you turn on slow query logging on your cluster, it'll say, hey, any query over 100 milliseconds, write it to CloudWatch logs, right? And that's another part of decoupling decoupling the monolith is we're actually sending that telemetry to an entire different AWS service. So when you have to go run the queries on, say, hey, give me the top 10 slow queries over this particular time period, you're not running those queries on your production database, right? That's an entire different service that you can use to segregate those workloads. One that I love the most is cost savings, to help you folks save money. And I mean this with all honesty. We launched R5 instances this year. Now, we talk a lot about price cuts at AWS. R5 instances for like instance types, right, R5 large versus R4 large, are the same cost. Not a price cut, but R5 instances are, right, that's the next generation of hardware. We see folks getting up to about 100% better performance for the same cost, right? Per price performance, that's pretty good. So if you're running on R4 instances today, friends, go into the console, modify your instance, scale to the R5s, and you're gonna get a lot more bang for your buck. We also introduced stop-start cluster, right? Conceivably, on a good month, there's 160 working hours in a month. There's about 720 to 730 total hours in a month. If you're not using a cluster, start-stop can help you save a significant amount of money. Per second billing on instances, right? We went from per hour to per second to make it even more granular so you're only getting charged for the things that you used. Cost allocation tags, right? So you can actually go in and say, hey, for this given cluster, I want to tag it, and then go into your cost explorer and then be able to say, okay, for this particular cluster, storage instance, IO, and backup, what were the costs attributed to this particular tag? I know how unsatisfying it can be at the end of a month because I get a bill too, just like you folks, of saying, great, I spent $500 in US East on DocumentDB. Well, I have 10 clusters. Like, which ones of those spent the money, and how do I do attribution? So those are some fun things. I know there's some stuff in this category you folks want us to build. We will do that. I know very well. You've told me many times, so we will do that. All right, so let's do a few more demos. All right, so from time to time, somebody will come to me and say, I would like to query DocumentDB from the browser. How do I do that? Is people familiar with Cloud9 as a service on AWS? The cloud-based IDE, super cool in its own right. Also, extremely powerful in browser experience to be able to query and manage DocumentDB. Not only do you get the IDE, but you get shell access to an EC2 instance. Why is this valuable? Some corporate firewall policies don't let you SSH out into EC2 and all this other stuff because DocumentDB is in a VPC. This gives you web browser access to be able to do that. So let me go in and query my document database. Let me log in. Right, so I can say something like DB, right, and I can query this stuff within the browser, and I have John Doe in here, and he's got a pretty good fraud score of 0.024. So that's in-browser querying, and that's pretty cool, that's pretty useful. What a lot of you folks come into me and say is, hey, it'd be really cool if I could query DocumentDB with a SQL interface, right? And they say, like, a lot of people that know SQL, not big on the Mongo API, or have a tool chain that uses SQL. Can we query DocumentDB with a SQL interface? Well, that's a pretty good question. I don't know if anybody saw the pre-announcement last week by the Athena team, Athena Query Federation. It's a pretty big, I like this new pre-invent stuff, right? All the launches before reInvent, it's kind of cool. To me, that was the biggest one and the coolest one. Let me tell you what that is. Athena launched the ability, and we'll go into the management console and go into Athena. So Athena, for folks that don't know, is our serverless query engine that basically allows you before the launch to apply SQL to stuff that sits in S3. After this launch, they added multiple different connectors that you can query over multiple different data stores. One of those was DocumentDB. So here's a select query, right? Same thing that was running before, and nope, can't highlight it when you run it. It takes what you highlight and actually runs it. Same query that we were running before, but using SQL, right? So I can now apply this to the data that's running in DocumentDB, and I can go back down and I can say, like, hey, here's John Doe, fraud score 0.24, and I can even go in and I can start using how I know SQL to refine that query, and that's available. This connector for DocumentDB is available. It's open source. It's extensible. Folks can do what they want with it. And that's pretty cool. But wouldn't it also be pretty cool to say, like, well, if I can query SQL data or across DocumentDB, wouldn't it be kind of cool to be able to join that with multiple other different databases? Like data that I have sitting, say, in Redis or DynamoDB or some other data stores. So they did one better, right? This is where the federated query bit is about. Selfishly, I applied it just to DocumentDB, but I will give you the full picture, right? So let's go ahead and look at this query. This query, if you can imagine yourself in the position of a decision support engineer, right? A lot of systems and applications, right? You might be using CloudWatch, you might be using EC2 instances, Redis, DynamoDB, DocumentDB. What if customers come in and start saying, like, hey, we have some orders that are getting stuck, and you're a decision support engineer. How do you go about debugging this? Are you really going to log into all these different systems? Like, that becomes pretty complicated. What if you could run some very high-level troubleshooting queries against all these different data stores, right? So what this query does is it goes through and it basically greps CloudWatch logs looking for anything with order IDs, right? It goes into Redis and it picks out all my active orders, goes in and queries my EC2 instances, takes my customer data and addresses from DocumentDB, takes my order shipments from DynamoDB, and my payment information from HBase, prints those out, joins this all together, and produces a single result set. Now I can go and look at this, right? I have my Redis order IDs and my customer information from DocumentDB, and I can start looking across these logs, and I can say, hey, I'm starting to see some warnings in this order processing log and some errors, and I can kind of scroll across, and I can see, oh, they're happening in the same EC2 instance. Maybe I should go take that worker out of the loop or go investigate and pinpoint my investigation there. And very quickly, I was able to look across multiple different siloed data stores, if you will, and query across the top of them using one SQL query language. Pretty cool capabilities. All right, so federated query for Amazon Athena is in preview. It's available today. There's a nice blog out there. There's some really great documentation and code out on GitHub. Again, this is all open source. And looking forward to getting folks' feedback here while this is in preview. Oops, sorry, I will go back. I'm sorry. Okay. All right, so what's next? If you haven't used DocumentDB, there's a really great getting started tutorial in the documentation. There's both words, and if people don't like words, there's a video to kind of go through the step-by-step process. I am more of a visual person, so I created a video because I like looking at those better myself. If you're thinking about migrating to DocumentDB, first there's another talk on Wednesday, and that talk is going to be on a customer, FINRA, who migrated from a relational database to DocumentDB because they really wanted the flexibility of the document model. And that talk is going to be really good. Jeff Duffy, our solution architect, is going to talk about different methodologies of migrating to DocumentDB. Of course, if you're migrating to DocumentDB, you can use the database migration service for free for up to 6 months for their free tier, which is really nice to get going on that. And then the question I get asked the most, what's on the roadmap, Joe? Well, I'll tell you what I never hear from you folks. I never hear these things. Can you please make it slower, less available, less MongoDB compatible, and more expensive? Like, you never tell me that. Usually it's like violently on the other side of it. So that's what we're going to be working on. We're going to continue to work on performance and high availability. Right? We have a lot of feedback from you folks on what you want us to build next as far as support in the MongoDB API, and we're going to continue to iterate on that. And we're going to have a lot of fun doing that. So we look forward to continue the feedback, whether through Twitter or Stack Overflow or your account team or on the forums. It all goes back through me one way or another. So if you have feedback that you want to give, we're definitely listening. Some other sessions this week that would be worth your time. Again, the session on 372 on Wednesday is going to be a great one. There's a few customer sessions, the last two, and then for folks looking for hands-on experience on migrating workloads, there's a few workshops as well. So with that, friends, I thank you for your time. I know you have choices of other presentations to go to, so I thank you very much for spending the time with us. Thank you so much to Entra for coming up and sharing their experience for us. Have a great reInvent, and please take some time to give us some feedback after the session. I have stickers for folks that want some. I'll put those up front, and if you have any questions, Entra and I will be right here for you. So thank you so much, and have a great reInvent.